Let's check out our problem of the day. Problem of the day says, find the slope of the line containing -3, 5, that's a point, that's an x and y coordinate, and -6, 3. Now we got another line containing 7, 3, and 4, 1. So it's two different lines we're looking at, folks. Here's the deal. So what conclusion can be made about the lines that we have here? There'll be two of them, all right? They're distinctly different. Again, find the slope of the line containing the point -3, 5 and the point -6, 3, and the line containing 7, 3 and 4, 1. Again, those are x and y coordinates to find a line. So let's check it out. Let's see what's going to happen there. First of all, formula. One of those that we learn back in 5th, 6th grade, and it just keeps coming and never goes away, So let's talk about it. What is it? First of all, I like to use the phrase, the slope equals, and we use m, by the way, for that. And I understand people saying, why do you use an m? Because I don't think it looks like an S, all right, which makes it look like a 5, all right? So we want to come up with the m there. That's what we've got there. One of these days, someone will enlighten me on that and say, oh, this is why it happened, all right? I'm sure there's an interesting story behind that. Anyway, I digress a little bit from time to time. We have a formula. I'm going to use two words. Many of us have learned it with this way, is rise over run. And when we talk about rise and run, rise is basically the change in y. I like to think of the y's rhyme with rise. Y's and rise, y's and rise. So y's are going to go on the top. Run doesn't rhyme with anything. It's just what's left over. It's going to be our x's, a change in x, if you will. So let's take a look. When we say change, we're talking about subtraction, all right? So we'll take y, the second y minus the first y. We could put first y minus the second y, but once we pick our order, we've got to keep it the same way for the x's. So if we pick the second y, we've got to start with the second x, and we're going to subtract that for the run. That's the difference horizontally. The rise is a vertical fashion, and we think of the y's obviously being vertical. Our coordinates are going up and down, all right, where we find them. So here we have it. We've got the numbers. Now it's substitution time. Now we're just going to work with these two right here. Save your thoughts, because we're going to do the same thing with 7, 3 and 4, 1 here in just a second, all right? Now, first things, let's take a look. I have y2, let's see. You say, well, how are we going to figure all that out, Ernie? How about this? We'll let this be x1, y1, and we'll let this be x2, y2, right there, all right? So, and by the way, that means first y, first x, first y. This is the second, doesn't mean square it. It's the second x and the second y. That's what these are all about. So be careful. We're not going to square any numbers on this. We're just going to work straightforward subtraction and see what happens with the fraction. Let's see what we've got. Going across the top with my y values. Looks like I chose the second one to go first, so how about it? We'll put 3 minus 5. Again, it doesn't matter if I go 5 minus 3 or 3 minus 5, but once I start, I got to keep going the same direction. I cannot change in the middle. Otherwise, I'll be off by signs, all right? So keep that in mind. You get your start, you got to finish. All right, so we went with 3 minus 5, so here we go. I'm going to say -6 minus a -3. Now, folks, when we get those 2 minus a -3, that's like saying plus a positive. We're going to use, one of our callers yesterday, Ron Coggins, said, an additive inverse, this is the additive inverse moment. We're going to add the opposite, which is going to be adding a +3. So here we go. I get -2, -3, and it's division. All right? So you say, well, can we leave it like that? Well, we can, but what's a negative divided by a negative? It's going to give us a positive. Now, 2 over 3 is not going to reduce, so we've got a slope of 2/3. We'll talk about that here in just a second, all right? Hold on to that thought. That's what it asked for, right? So we've got our first one. Let's do the same thing for our second one. All right, we're going to start back again with slope equaling rise over run. And in this case, it's still y's. Subtract them, and then take your x's and subtract them. Second y minus first y, and so forth. Now let's go ahead and make sure we keep it straight. I think it's nice to put little things over if you have trouble, especially when there's a bunch of points running through here. Now let's go ahead and we're going to call that our first x, first y. Here we go, second x, second y, and run the formula once again. This time looks a little bit easier because everything's positive. Well, let's see what happens. When we put 1 minus 3, we get a negative. And underneath that, we would have 4 minus 7, because those are your x's. And notice something, we get a negative 2 over a negative 3. Same thing again, right? Which equals 2/3. So your first conclusion is, Ernie, those slopes are the same, all right? So that tells me the lines have the same slope. What can we tell about those two lines? They're going to probably, in fact, in this case, they're going to have to be parallel. Now, I say they're probably parallel because they could actually be the same line with just different points on that line. So you got to be careful on that. But definitely, we're going to go with the thought, are they parallel? So let's test it and see, are they going to be? So let's look at a graph. Let's take a little look at a graph here. I'll bring my graph papers in here, and we'll keep these numbers that we've had here. Let's go back to a graph here, and let's plot some points, all right? First of all, negative 3, 5. I'm going to go to the left 3 and up 5 spots, all right? I'm going to also go 6 to the left, 3, 5, there's negative 6, and go up 3. And we have a line developing there. Oh, yes, we do. Let's get a line drawn through here. And looks like right there it is. Pretty nice. And that's got a slope of 2/3, so running on up through there. So we connect it. Looks something like that. Let's do our other 2 points. Our other 2 points, we had 7 and 3, so we'll go out 7. Because remember, there we go x first, and then we'll go up 3. And we'll go out 4 and up 1. And there's our second line appearing, and it looks pretty good. We'll connect them. And let's see, make it good. And here we go. And look at those lines. They have the same slope, and they are running parallel with each other. So pretty good show there. They do not intersect. They stay the same distance apart. So answer to the question, twofold. They have same slopes, which means they're going to be running parallel, especially since when you plot them, there you have it. All right.